Hey everyone, just getting things set up so we can take a look at our next video. We're going to be looking at the last section actually in our Unit 2, Chapter 3 and 4, where we've been studying quadratic functions. This is section 4.4, where we're taking a look at the quadratic formula. Our objective is to take a look at where the formula came from and then to just use it a little bit. Make sure you watch out for a few things in terms of vocabulary. We'll mention something called imaginary numbers, roots, and discriminant. So make sure you copy those down, and as you're taking notes, that you're watching for those descriptions and meanings. So we've been exploring how to find the x-intercepts of a quadratic function. We started with graphing. We took a look at factoring. We learned how we could use the process of completing the square. And today we're going to be taking a look at something that's familiar to you, actually, because you know when you cannot factor that you can go to the quadratic formula. We learned about this one. And remember, we learned it as a song so that it would help you remember to memorize it. And I think most of you have it quite well memorized as a result. What like to look at today, though, is where did this formula actually come from? Was it simply magic? Did someone put a mathematician in a room and just say, you can't come out of there until you've actually come up with some kind of a magic formula that will help us find any possible root of a quadratic function? Well, it's nothing like that. So we're going to take a look at it today and see if we can follow it through. What we're going to do is start with the standard form of the quadratic equation, and we're simply going to follow through the process of completing the square. So the first thing we're going to do is divide everybody by the coefficient a to get rid of it from the front of the x squared. So this will be b over a and c over a, and we'll just throw that over to the other side. Now we're going to make this a perfect square. So we take b over a and divide it by 2, which means it's b over 2a. And when we square it, it's b squared over 4a squared, which we add to the left and to the right. Now that means we know that this came from x plus b over 2a, all squared. And then I'm just going to put this all together in the denominator of 4a squared. So I'm going to have to multiply this guy by 4a, which is where I get negative 4ac. Now, mathematicians are a little bit over the top for sure. They don't like leaving a negative in front. So what they would prefer to do is put the b squared in front. So you'll see that down below. And all I'm doing is taking the square root of both sides. So it's x plus b over 2a and the square root of this thing. I'm going to move that b over 2a over to the other side. And then I'll take a look at this. Really, I don't want to touch this part because there's no perfect square root of that. But 4a squared, the square root is 2a. And so I'll put it over a common denominator, and voila, you have the formula. It's actually very, very easy to get. Now that you understand the process of completing the square, you can understand where the formula came from. It's not where the formula came from. It's not magic at all. So using this formula, of course, can be daunting. There are a lot of details and it's easy to forget something. So here are a few things just to try and make it as successful as possible. I would suggest that you always check to see if you can factor first. It really is the easiest, most direct way to find something. But definitely, if you come across anything that looks messy, decimals, big numbers, whatever you want to do, just don't waste any time. Jump into the quadratic formula. When you substitute the numbers in, always put them in a bracket. It sort of keeps them safe until you have a chance to figure out whether they're positive or negative. Remember at the very end that you're going to have to simplify the radical. The thing under the square root sign is going to have to be simplified. So always take time to do that. And before you actually try to simplify the final answer, I think your best route is to break it into 2 separate fractions to reduce it cleanly. And if you're going to find an answer that is actually a decimal, please don't pick up the calculator till the very end. Try to just keep it out of your hand so that it doesn't end up making you confused in any kind of way. Okay, and so there are a couple of calculator tips that we've been using through the year that will help you. Remember, by using alpha y equals, you can find this setting, and it sets it up as a fraction, so you can actually type it in really easily. And also, once you've entered the equation for the first intercept, let's say you used plus the square root, we'll just go back up grab that formula, press enter, which will bring it back in, and go back inside and just change the positive and negative sign, and press enter again. It's a very fast way of doing these. Okay, let's find the roots of the following quadratic equation. All right, well, we move everything over. That becomes a positive 4 on the other side. We check to see nothing multiplies to be 36. Well, actually, that's not true. It does multiply to be 36 and add to be 12. It's true, we could factor this one, but I chose it very specifically because I wanted you to notice something that was going to take place. And so we're going to go ahead and use the quadratic formula, make an exception to my rule of always factor if you can. Okay, write your formula down, put your numbers in. Now, with all of these being positive, I kind of didn't follow my rule where I put everything in a bracket, but you will find that especially if it's a negative, I'm putting it in with a bracket, and it's just a good habit to always do it. Okay, when we simplify it, what we find is that this number underneath the square root sign is simply 0, and the square root of 0 is 0. So when we're finished, we have only one root. Now that brings up an interesting thing. You see, this seems to be really important in the equation. If it's a 0, then I'll have only one root. So the question is, well, what if this number underneath here turned out to be a negative? Well, if it were a negative, it would be an imaginary number, and there would not be any real roots. And then if it's just a plain old positive number, then it's going to give me two answers by adding and subtracting. So I would have two real roots. What we're doing right now is we're looking at the various possible solutions that you can have with the quadratic formula, scenarios, if you will. Your answer can have two intercepts, one intercept, or no intercepts. And what we use to be able to determine that is something we call the discriminant. The discriminant is this part under the square root sign. Now, it does not include the square root sign. Be careful of that. It's simply b squared minus 4ac. And what we do is we check to see, for instance, if that discriminant is a 0, we know that we will have only one root. If it is less than a 0, in other words, it's negative, we know that we won't have any real roots. And then if we know that it's anything larger than a 0, we know that we have two real roots. That leads us to the type of question like the following, where they say, use the discriminant to determine the nature of the roots for each quadratic equation. So what we will do is simply take that little thing under the square root sign, b squared minus 4ac. We plug in the numbers, find our number, and find that it's a very positive number, which means that this quadratic function will have two distinct or two real roots. And sure enough, when you graph it, you can see it has two places where it crosses the x-axis. Next one. Move everything around so it's in standard form. Check the discriminant. Turns out to be a negative 83, which means there are no real roots. In other words, there are no x-intercepts. We call this an imaginary root. And just in case you're wondering, we've looked a tiny little bit about imaginary numbers, and what they are is a tiny little I, which takes the place of the negative 1. Now, we're not going to study it any more than that at this level. Later on, you'll learn a little bit more about the imaginary numbers and how to simplify them. But let's take a look at the x-intercepts. Sure enough, here's my graph, and it has no x-intercepts, just as we predicted. Lastly, we'll take a look at this one. We'll take our numbers and plop them in. We get a 0, which means if we check the graph that we should have only one real root. And sure enough, there it is, just the one. Okay, so really when it comes down to it, if you're given an option, you're thrown a quadratic equation and asked to just simply solve it, what would you do? So let's walk through it. The first thing I would see is it's got a common factor, so I'm going to take out a 2. Then I'm going to check to see if it factors. What multiplies to be 4 and adds to be negative 7? Well, sure enough, it does have those two numbers, so go for it. Split up the middle term, take out the common factors using the factoring by grouping, and then you have your factors. No need to use the quadratic formula unless you really need to. And here is an example of what this guy actually looks like. So use your common sense to choose the best strategy. I'm going to take a look at one word problem in this video. Now, this one is where Leah wants to frame an oil original painted on canvas measuring 50 by 60. Before framing, she places the painting on a rectangular mat so that the picture is essentially framed by the uniform strip of mat on all sides. Now, please notice this is a rectangular mat. It does not have a hole and it's just a piece of cardboard, and she's placing the painting on top of it. The area of the mat is twice the area of the painting. How wide is the strip of the exposed mat to the nearest tenth? So let's take a look at how this guy is set up. We're going to talk about X being the width of the mat around the outside. Okay, so the area of the mat would be simply, you've got this big mat all along here. Um, we know that the mat is twice as big as the painting itself. So that's why it's 2 times 50 times 60. We know that one side would be 50 plus 2 x's, and one side is 60 plus 2 x's. And then we're simply going to solve. All right. We go ahead and expand this, put everything over. You end up with a quadratic equation that looks like this. I've chosen to use the quadratic formula so I could find it and plunked things in. And actually, in this one, I don't worry too much about simplifying. I simply use my calculator, come up with two answers. The negative answer, of course, is an extraneous solution, doesn't make sense in the context of this question. And then I discovered that the width of the exposed strip around the outside of my painting is about 11.3. Okay, there you have it. Using the quadratic formula, here is your homework. Please make sure you go through each question and come if you have any questions at all. Good luck, everybody.